In this video, I'll demonstrate an implementation of the AJAX paging pattern using the ASP.NET extensions for AJAX. From a user experience perspective, the interface for the AJAX paging pattern is relatively simple. We'll have an area of content that becomes a single page window into a larger document like a magazine article, with some forward and back navigation buttons that the user can click on to fetch either the next page in the article or the previous page in the article, depending on what the current page that the user is looking at is. The logic behind implementing the AJAX paging pattern is a little bit more complex, though. The paging pattern is actually a composite of several patterns, namely the predictive fetch pattern, the caching pattern, and these are necessary so that when the user is navigating through the article, they don't have to wait for the server to return the page that they've requested. That moving forward through the article, pages are predictively fetched, and backing up, looking at previous pages that they've already viewed, the most previous page has been cached. We also have to implement two different state mechanisms. One is the state of the chronology of the page, so they're currently looking, what page they're currently looking at, and that state has some extrapolations, meaning which page is next and which page is previous. We also have a second state mechanism that we need to implement so that while we're doing the fetching, which is happening asynchronously, we can maintain the integrity of the user interface so that the user's overzealous clicking away at the buttons doesn't corrupt the page state. So there's some fairly complex logic under the covers. So to get started, we'll fire up Visual Web Developer, create a new AJAX-enabled website. Call it article paging. And the first thing I'm going to do before we get started is I'm going to add some article data and a cascading style sheet. So I'll just grab my CSS file and drop it into my solution. Now, you notice I've got some text files here, and these text files contain just, actually it's tough to see the markup here, but this is just a collection of paragraphs, just sample data, and these four text files represent a 4-page article. So I'm going to drag those into my solution into the app_data folder. Now, you can store your article data in several different ways. I've stored them in text files here. You can store them in XML files or HTML files if you want to do the processing. But remember that they're not going to be full HTML pages. They're going to be just document pages. So as I showed in our case, they're just a collection of paragraphs that have content to be displayed. You could also store these in a database, which would make things a little bit simpler in terms of things like figuring out how many pages are in the article. But in our case, I'm going to use a text file so that you don't have to do anything fancy, and we can focus on the implementation of the pattern rather than the details of parsing markup language or populating and retrieving the articles from a database. So the first thing that I'm going to need here is I'm going to need a service to return the article pages. Now, doing this with a AJAX service method is only one of the ways that we could be getting content. We could also retrieve documents directly without going through a service, and I'll demonstrate that in an upcoming set of How Do I videos. But in our case, we're going to use a service method, and I'm going to place code behind, and we'll call our service page fetch. The first thing to remember is that because we want this, the methods in this class to be callable from JavaScript, we need to decorate our class with the script service attribute. Next, we'll replace hello world with a getPage method, and our getPage method is going to require two input parameters. First, we're going to need the article number. So what's the number of the article that we want to fetch? And then secondly, we're going to need the page number. So which page of that article do we need to fetch? And let's get rid of hello world here. And now I'm going to, just so you don't have to watch me type, I'm actually going to use a snippet. So we'll include the snippet, and we'll walk through the code in just a second. Notice that StreamReader is not recognized by default, and that's because we have to import the namespace system.io. Now let's go ahead and look at the code. So here are input parameters. We have just to dim up a string for error diagnostics. We dim up this path to contain the path of the content. This is going to contain the contents, the HTML markup that we're going to pull out of the text file. Note here that I'm building the path to the file that contains the article page that we want to return. So I'm doing a map path. All of my files live in the app_data folder. I'm starting with the article number, adding an underscore, then adding the page number, and then appending .txt to the file extension. And you'll note that that's the file format. So I'm using the file names as the arguments that will be required by the web service. So notice the 1, 2, 3, 4 is the article number, and there's the underscore that we've appended, and then 1 is the page number, and then .text. Right. So, and then we're doing all we're doing here is the first thing I'm doing is before I actually open and read the article, I'm putting the thread to sleep for 2 seconds. You obviously don't want to do this in your application. The reason that I'm doing it is because my service is running on the same machine as my browser. The response is too quick, but I want to be able to demonstrate that second state mechanism that I was talking about, that that basically freezes the user interface of the paging patterns implementation while the network call is taking place, so that we don't corrupt the page state. So that's just this thread sleep call is just for demonstration purposes. Now here in our try catch block, I'm just going to open up a stream reader, suck in the contents of the file that we just opened, and then close it, and then return that contents in the service. However, this exception handling is really important here, and I'll show you when we get into the JavaScript logic. But you probably want to do some more detailed error handling here. In our case, we are assuming that whenever the read fails, that it's because the document doesn't exist. You might want to do something that's a little bit more detailed here, maybe checking for permissions or what have you. But we're just assuming that if the read fails, it's because the file name doesn't exist, and we're returning this string literal EOA for end of article, and we're going to use end of article as part of our state mechanism. All right, so now we're ready to go ahead and start programming over on the client. So the first thing that we need here on the client side is to include a reference to our cascading style sheet so we can use the classes that are defined there. The next thing that we're going to need is an area that the user can enter the article number into and click on a button to retrieve the first page of the article that they specify. So let's go ahead and add that. And remember, we want to do this not using ASP.NET server-side controls, but instead using HTML artifacts, because we're going to be doing all of the heavy lifting in this implementation using JavaScript rather than VB or C# code behind. So we'll add an HTML text box and an HTML button. And I'll call that text article number. And just for my fan out there that takes issue with my seemingly random naming conventions, I'll call this button article by number, and let's change the value to fetch. Also just add a little couple of horizontal rules here just to delimit. Next, we're going to use this div as the container for our page, so that we can program against it in JavaScript. Let's give it an identity, and we'll also give it some visual aesthetics by assigning a stylesheet class. There we go. I'm also going to add a few ASP.NET labels here, and we'll primarily manipulate them from client-side code. Right? So let's do that here. And what these are just going to be is these are going to be the some header information to provide a little feedback to the user. So this is where we'll say, for example, page 1 of 6. So let's call the first one label page title. We'll call this one the current page, and then we'll call this one label page of, and I'm going to leave them empty by default. We'll populate them from JavaScript code. Okay, and then the last thing we're going to need is navigation buttons. So again, we're going to use HTML and not server-side controls for this. So these will be our previous and next buttons. And the values we'll set to previous page and next page. One other thing I want to do here is I'm going to set these buttons to disabled by default. And the reason I'm going to do this is that enabling and disabling these buttons is how we're going to prevent the user from interrupting the asynchronous calls and confusing the state of the page. That'll make more sense once we actually get to the implementation. So here's our page, and here's our here are our buttons, which are disabled by default. Now we can go ahead and start programming the JavaScript portion of our page. So to get started, I'm going to double-click on our article fetch button, which will shell out the script code section for us and let us give us an area to start writing the JavaScript. So to begin with, we're going to need some local variables that we can use to manage state. So we're going to start with a couple of variables that will be buffered pages. So page buffer next will be the article page that we're going to predictively fetch. So the user's looking at one article and we're going to fetch the next one. We're also going to have one for the previous page. So the user has looked at a page, forwarded to the next page, but we're going to keep the page that they just looked at around in the cache for a little while. So this is how I mentioned that this is an implementation of multiple patterns, including the caching pattern and the predictive fetch pattern. We're also going to need a current page indicator. And we'll initialize it to 1 because 1 is going to be the first page that we fetch. We also want a last page indicator. We're going to set the value to -1 because of the way that we're storing our article pages as text files. We won't actually know what the last page is until we try and fetch another page and get a failure. So also something to contain the article number. And these actually don't want to be in the function, they want to be up here. Okay. Now we can program our get article by number on click event, and so that you don't have to watch me type all this out by hand, I'm going to use the magic of cut and paste. but we'll explain all of the code. So here the users entered the article number and clicked on the fetch button, and first thing we're doing here is just setting up the some of the labels on the page. So now we can add the page header, and remember we don't know what the how many pages there are, so label page of is still going to be blank, and then we can specify what the article number is going to be. Because that's been retrieved, we can set the current page, which is going to be equal to 1 by default, and then we can fetch the first page of the article that was just entered. Right? So once we've done that, remember that this get page is not a direct call to our service method, but in fact is a call to the JavaScript callable proxy to that service. And hopefully you've been watching the other How Do I videos, so I don't have to go into the detail about how that works. But if you're new to it, go ahead and check out some of the previous How Do I videos, particularly on service calls, to understand what actually happens under the covers. But here's the first input parameter, the second input parameter, so our article number and a page number, and then here are the other input parameters that are required by the proxy, and that is what JavaScript functions to call on successful completion, if there's a timeout, or if there's an error. Now, for timeouts and errors, I've just got a block of error handling functions. Notice all they do is pop up alerts, and obviously in your production code you may want to do something a little more creative and just pop up an alert to specify that there was an error. But for the purposes of our demo, that's fine. The next thing that we want is the onComplete function. So if when page get completes successfully, we'll call this function. And what we're doing here is we're saying, now remember, this gets called when the user has entered an article number, click the fetch button, the first page is retrieved, and what happens is either if there was an error, meaning the article probably doesn't exist, since on current complete happens inside the click event handler for the fetch button, which means that we're trying to fetch the first page of the entered article. If we get an error here, that likely means that the article number that was entered is invalid. There's no article that matches that number. So if we get that end of article indicator, we're going to set all of the header labels equal to empty strings, and we're going to provide an error message that says invalid document number. Otherwise, we successfully retrieved a page, and we're going to take what we got back from the service call, which is the first page. We're going to stick that into the inner HTML element of the page view div, and then we're going to predictively fetch the next page. Right? So we're going to notice working with the same article number, but we're saying go ahead and fetch current page plus 1, and now we have a different onComplete method. All right, so while we're predictively fetching, again, if we're predictively fetching and we get an EOA return from our service method, that means that we found the last page. So we'll set the last page equal to the current page, the one that's being displayed, and now we can specify the additional label at the top. So we can say page 1 of 2, for example. If we didn't get the end of article, that means that we successfully retrieved an article. So we're going to take the results from that service method and put that, which is the HTML that's returned from the article file back on the server, and we're going to put the values that's returned back into our page buffer underscore next variable, so that it's just sitting there waiting for when the user says, I want to see the next page. We don't have to wait for the service call to return because we've already made this service call for that page number. Right? And then we're going to say button next disabled is equal to false, and button previous disabled equal to false. So we're going to turn those buttons back on. Right. Now we need event handlers for our previous and next buttons. Okay. So here in our next button on click handler, first thing that we do note is that we turn both of the buttons off. And what we're trying to prevent here is the user sort of just rapidly clicking away on the next or the previous buttons. So what we want to happen when the user clicks on the next button, first thing that we're going to do is turn those buttons off. We're then going to take the predictively fetched page, put that into the div, and then we're going to go fetch the next page. And it's not until we fetch the next page that we're going to turn those buttons back on, right? So what we don't want to happen is we don't want the user to too rapidly click on the previous or next buttons and cause the current page counter to fall out of sync with what's being returned back from the server. Right? So in this case, we're saying if the current page is equal to the last page, then we're not going to fetch anything. We're just going to set previous disabled equal to false. That means we're sitting at the last page, so we're going to allow them to back up, but they're not going to be able to go forward because they're already on the last page. Otherwise, the current page is not the last page, and so then what we're going to do is we're going to save the current page into the previous buffer. Then we're going to put the predictively fetched page into the page view div, increment the current page number because we're moving forward, right? So we just because the user clicked on that view next page, right? Then we're going to refresh the page counter in the label, and then we're going to fetch the next page. So this is the second implementation of predictive fetch. Remember, the predictive fetch happens here when the first page is retrieved. So we go ahead and fetch the second page. Now the user is navigating, and because they're navigating, we're going to say go ahead and display the page that's been buffered and fetch the next page that the users might want to look at. Similarly, with navigating previously viewed pages, again, we're going to say set both buttons to disabled. If the current page is not greater than 1, that means that we're on page 1. So we're just going to say go ahead and turn the next button on. If they're on page 1, there's no previous page to go to, so we don't have to turn the previous button on. But otherwise, we're going to buffer. Because we're backing up, we're going to buffer the currently viewed page in the next buffer. Then we're going to display the page that's stored in the previous buffer. We're going to decrement the page, set the page number label that's at the top of the div, and then, if appropriate, right, after we've decremented the page, we're going to check the current page number again, find out if there is a previous page, and if there is a previous page, then we're going to fetch it, and then re-enable the button, the navigation button. Right, so just the inverse of what we did when we were moving forward. One other thing that we need to do here is we have one more event handler. we need an onComplete previous method. And we're just going to store the result that's returned from that service method in the buffer so that it's ready if the user navigates in that direction, and then enable the button. Now, of course, if we want to be able to call, if we want these JavaScript calls to successfully call our service method getPage, we're going to need to tell the script manager that we're going to be calling them. So let's go find the script manager, add a services collection to the script manager, and then add a service reference to now we can go ahead and give it a try. So if we enter the article number 1, 2, 3, 4. Notice page 1 appears, but the buttons stay grayed for just a little bit. Now we can start to page through. Notice page 2 appears instantaneously, but it takes a second before the buttons reappear. So each time as I click a button, the page that I'm specifying that I want to view appears immediately, but it takes a little while before the page catches up, and that's the latency for the service method call that we're calling in the background via JavaScript. So that's it. That's all it takes to implement the paging pattern in AJAX using the Microsoft ASP.NET extensions for AJAX. It's a great way to really improve the aesthetic performance of your AJAX-based user interface.